For this chapter, we're going to talk about geometry. And so we're going to talk about like perimeter, area, volume, things like that. But we are going to start with this discussion, we'll say, on lines and angles. And unfortunately, we do have to start with a bunch of definitions. And I never like to do that. Like one or two definitions is great. We got a bunch of them here. But let's see what we can do with this. So first we have that geometry is the branch of mathematics concerned with the properties and relations of points, lines, angles, surfaces, and solids. Okay, so that's really broad. Okay, but just think kind of the math of shapes is sort of how I like to think of it. Okay, so that is our first definition here. So let's go to yellow again. Okay. Now, first definition, first topic that we're going to look at is understanding lines and rays. So we're going to start this kind of the heart and soul of this section is going to be lines and angles, but we have to kind of build the idea of an angle, and it takes quite a few definitions to get there, okay? So the first definition we have is that of space. So we're not necessarily talking like outer space. We're talking about space where shapes live, okay? So space extends in all directions indefinitely. So up, down, left, right, every direction you could perceive, that is what we think of as space. And don't get too hung up in this, and we don't talk about space a lot. Now, a plane, okay? A plane is a flat surface that continues in all directions indefinitely, but it's got to be flat. So it'll go like left, right, up, down, diagonally, but it won't go like three-dimensional. Okay, so think of like kind of a two-dimensional flat surface, but it does expand. So space is kind of like everything in a room, like like knock down your walls and it just keeps going forever and ever and ever and ever. But then imagine keeping one wall and letting that wall go up, left, right, and down forever. That would be a plane. So space is kind of like everything, and then imagine a wall that just goes up and down, left and right forever. Okay, so that would be a plane. All right, now don't get too hung up on those two, okay? So we do go into kind of plane figures and we plot and graph things on a plane or whatever. Just know that a plane has two dimensions, length and width, and it kind of goes forever. So again, imagine space forever. So you have a room or a house, you knock down all the walls except for one, you get rid of the ground, you can just go in literally any direction forever. A plane is going to be that wall. It goes up and down, left and right forever. So it has length and it has width. That's it. Okay. Now we're going to get to the nitty gritty, the stuff that's really, really going to matter for us. We have a point. A point is a location on a plane. So it's just one teeny tiny location. It's a point. Okay. Now, a point is generally represented by a dot with like a label. We'll label it like point A or point B, but it doesn't have any kind of length, width, or depth or height. Okay. It's just a location in space. We just use a dot to represent it. Okay. Now we're getting to what's really important to us. A line. So a line is a one-dimensional figure that extends in opposite directions indefinitely. So if we're thinking about the dimensions it contains, think length, okay? So it is customary to name a line by 2 points on the line. So we have this line that goes forever. We'll indicate 2 points and we'll literally like name them usually letters. So like we'll say this is line AB, so we'll figure out where point A is, we'll figure out where point B is, and that's our line, okay? So the line that goes through points A and B would be denoted as follows. So do kind of understand this notation. So you put whatever your labels are. So you find those 2 points on your line. In this case, we're using A and B. And then above AB, you'll put like a little line. Make sure you put little arrows on the end of it. So that would indicate, hey, this is line AB. Okay. Now we have a line segment. And so this is always kind of funny to me because, like, imagine you're in first grade and your teacher is making you draw some kind of a figure and they're like, draw a line. What they really technically should say is draw a line segment because a line goes forever. Okay. It's this one-dimensional thing. It has length and it goes literally forever and ever and ever. Okay. A line segment is like a segment of a line. Literally, it is what it says. It's just like a little chunk of a line, but it has two definite end points. So it doesn't go forever. It's only one dimension. It has length, but it has a very finite length that has a beginning and an end. Okay? So a line segment is a section between any 2 points on a line. Okay, a line segment is named by its two endpoints. Okay, a line segment that has endpoints A and B would be denoted as follows. So again, you have these points A and B, and you have a line segment, like a little miniature line segment on top. So it's a little line that does not have arrows. So that's how we differentiate between a line and a line segment. A line goes on forever. We put the little arrows. A line segment has a finite length. It has endpoints, so we don't put the little arrows on the end. Okay? And then finally, we get to array. Okay? Array has one endpoint and extends in one direction indefinitely. Okay? So if you want kind of a visual, let's say we have some endpoint and then we want to extend in just one direction forever. Okay, that is array. One endpoint and then it extends in one direction from that endpoint forever and ever. Okay, so array is named by its endpoint and then one point on the array, the line part that extends. Okay, so imagine we have this endpoint, let's call it A, and then we have some point on the array, let's call it B. We would name this ray AB. So just like in the previous examples, we would just put those two letters side by side, and then on top of them, we would put like a little miniature ray. So one endpoint, one arrow, okay? And that would be the ray AB, okay? So let's look at some examples. Lots of definitions, not too bad. They all kind of just build on each other, which is nice. Okay, it says determine what each image represents. Well, for part A, we have 2 points. Whoops, let me go back to my marker. So we have 2 points. Point A and point B. And notice they're indicated with just a dot and a label. Okay, so that's how we deal with points. And remember, points just represent a very specific location in space or a very specific location on a plane. Okay, part B, we have definitely a line here. You can see that we go forever in both directions. That's what those arrows indicate. And we have very specifically line AB. So this is a line, and it's very specifically line AB. So we would write it like this with a little line on top. Okay, and then part C, this is what a line segment looks like. Okay. It's a portion of a line between 2 points. So you find any 2 points on a line and kind of take that little chunk out and you have a line segment. So we would call this line segment AB. And we put just a little line without arrows on top, okay? So we have just this little line segment on top. Nice endpoints, no arrows. Okay, and then finally we have array. This is ray AB. So we have a point A. There should be like a point here. I don't know if I copied this, stole it, or if I made it myself. But anyway, there should be an actual point there for B. So we have the endpoint and then any other point on the array. That's how we name array. So you would write those two letters together and then just put array, a little miniature array on top. So one endpoint, one arrow. Okay. So that is kind of the start of all this. In our next video, we're going to talk about angles. And you need to understand all of this to get to angles, but it's array that we really need to understand. So make sure you understand array has one endpoint and extends in one direction indefinitely. Okay. So make sure you understand what array looks like. All right.